It's going to help you guys figure out when and what to look for when you're using your calculator. No. For example, this one here is talking about a cannon. And the cannon has some model where it's starting to shoot shells. And one thing I want you to see here is the equation. Is there a value of C within this equation?
No.
So what is its starting point? 0. So what this means is that the cannon is starting at a height of 0, and it's shooting out and landing here. Okay. Obviously, it's got to be down like a frown because the first term is negative. So what goes up must come down. There's some maximum value. It asks you. It says that where x is the horizontal distance traveled in miles. So I know that this distance is the horizontal, which means this is the vertical. So it asks you two things. How far could it fire a shell, and what's its maximum height? Now, what's really nice about this is that you have the value at 0. What happens halfway? When you start at 0, the maximum occurs. Okay? When I'm at 0, I'm going to hit a maximum and then come out to the other side. So one of two things you can do. Remember about that axis of symmetry with the quadratics? The axis of symmetry is the opposite of b over 2a. Well, I can do this. I can take the opposite of b, which is negative 1.37, and divide it by 2 times negative 0.0196. And that's going to give me the x coordinate here. When I do that, that tells me the halfway distance of x. So how would I figure out how far it would go? Just double. Okay? I would just double that. So what I'm doing here is I'm thinking about what this looks like visually. Since I'm starting at a value of 0, going up and over, halfway from 0 to where it hits the ground and explodes and causes mass carnage, and you got to go to the pathologist to look at the fluids in your brains coming out, there was the maximum value. The maximum value occurs at the halfway point. So just figure out what the axis of symmetry is. There's your halfway point of x. Double it, and that's how far it shoots.
Wait, but I thought it asked for...
It does. To get the height then, that value of x that you find, you just substitute back in. There's your how high it shot up. You can. The other way you can do this with your calculator, and I was going to show you both ways. Was what? It was negative 0.0196.
Mr. Murphy, my hand really went.
I'm sorry. You were so excited.
I was excited.
I'm sorry. We'll clarify that. Better. So we put in our function negative 0.0196x squared plus 1.37. And I'm just going to hit enter for my graph. And again, I'm going to do my zoom out to see the whole parabola thing here.
Actually works on like the other.
Let's see. So that is menu 4. Thank you.
And then enter.
Oops, sorry.
A lot.
Whoop, too much. But anyway, you get the idea. So one of the things that we can do here is you can figure out how far it went. You can figure out the maximum. We can just do the calculate maximum. Let me go back and zoom in here a little bit.
Are we going to be able to like use our calculator for this like on the quiz and stuff like that?
Certain parts, yes. Oh, look at that. I can do that. Sweet.
But like if it's hard numbers, right?
Yeah, I will give you easy ones and other ones and stuff like that. Hey,
Wait, I'm trying to figure out this. I'm trying to figure out the ALS calculator.
Oh, okay. So what I'm doing here is I'm going to find that maximum. And in order to do that, we just hit our menu, analyze graph, maximum. My lower bound, I'm going to put here. My upper bound, I'll put here. And it's giving me a maximum value about 34.9. So my x coordinate would be at about 34.9. So in my graph, this is 34.9. Can I just call it 35 for
Yes.
rounding? I mean, because it's a lot of other decimals. So halfway, 35 miles, double it, you get 70 miles. I think we actually looked this up last year in Algebra 2. If we had the cannon right here at the school and shot it toward Chicago, it hits Lake Michigan.
Cool. Let's do.
No. So if you think about 70 miles out, you're in the water. Okay. The maximum height then at
That's
this,
really far.
23.9 miles up. So 24 miles up, 35 miles out is the maximum, and then it just goes down
So
from there.
24.
How far up do airplanes fly?
Airplanes fly usually about 35, 37,000 feet, which is about 5 miles up.
How do you know this? Did you do it in a word problem?
They like announce it when airplane.
That's awesome. That's quote of the day. Go write that down. How do you know this? Did you do that in a word problem? That's awesome.
I wasn't even trying to.
That was great. That was funny.
Wait, where do I write it?
On the window.
This is my second quote that I do it.
Okay.
I've never done it before.
So what I'm doing here is I'm just trying to figure out what did it mean, what does its values look like. Did you guys clean it up at all? Yeah. Did you just miss a decimal maybe? It's usually how it is. All right. Let's see. What was the next one you had to do then? The shot put. All right. The difference now between the shot put versus the one you just did is that this one has a C value, which means the shot put is starting somewhere off the ground. Does that make sense? It's got the shot put. And according to this, it says that the initial starting point of the shot put is 5.5 feet off the ground. So if you're looking at it graphically, it's starting here and landing out here. So in this case, I can't use that, find the maximum value and double it to see how far it goes, because the shot put starting at 0 has to go out, but yet it could fall behind. Does that make sense? Why it doesn't work to do that same little trick? Here I'd have to actually just put it in my calculator and use it as far as the maximum for the maximum height, and then find the 0 to where it crosses. One of two ways you can do that. You can just go into your table and just scroll through to figure out where it goes from positive to negative, or just hit calculate 0. It does the same thing. Okay? Does that make sense how that would work? It's a little bit different.
What is that?
Take ball.
Do you still have your like square eraser that you got from
I do, yeah.
after we lost her? What Katie lost her?
What?
Lost your foreign exchange student.
Oh.
After the shot put was the volleyball one, right?
No.
Airplane.
91.
Oh, was there a different one?
Firefighter.
The firefighter one, what happens with the firefighter one is that there's two different spots that you can get that value to work. So if I'm looking at this, you've got a good water stream can be modeled by blank, where x is the water's horizontal distance traveled in feet, and y is its corresponding height. A firefighter is aiming a good water stream at the building's middle, 25 feet above the ground. At what two distances can he stand from the building? Basically what this means is, again, you are starting at 3 feet off the ground. It's coming up, and it's coming down. Somewhere along the lines, this stream is going to hit a y value of 25 and 25, because what goes up must come down. So what that means is that there's two different spots of x that the fireman can stand on to figure out where the value is going to wind up being at 25. There's two different places you can be at. So what I would do for a problem like this is I would go into my y equals, put the function in, and then I'm going to look through my table and look for when you have an approximate value of y to be 25 feet. You should have two separate values. Or set that equation and set it equal to 25 and solve for x. It's a lot more of a pain in the butt, but it works. Okay? because there's 2 spots. Yeah.
Also, graph the line, that's just y equals 25,
Yes.
find the intersects.
Oh yeah, that's right. I never thought of that one. That works perfectly. That works great too. You everybody see what he's saying? What it's saying there? When you do that, you've got. Oh, wrong calculator. Where's my? The first one was negative 0.003. Was it 0.03? Thank you.
Plus 0.62.
And then plus 3. Why is it plus 3, you think?
Because it's really helpful.
Say hello to my little friend.
Plus 1. Yeah, one more.
She did 5.
I always see
So there's one of them, and then the other one we're going to add another graph. So we do another.
Oh my god.
Was it tab? Tab, right? Yeah. Hit tab and put another graph in, and what we're looking at is putting in a line at y equals 25.
Okay, that's not what mine looks like.
Well, we have to zoom out. That's why.
Oh.
No, I think you graphed it wrong.
I think you have like 0.62 squared instead of that.
Oh, yep.
Haha.
What is it?
Just
It's
X.
just that.
0.62x, not 0.62 squared.
Oh, yeah. There we go. All right, so now we do our zoom.
4, 4. Okay.
Oh,
Wait, why do you have the Y?
oh,
Murphy.
ah! Anyway, so you find out where those are. Look at your table. Look for an
Wait.
approximation where it's running across.
Where did the
Okay.
2?
After that, I think was the downward velocity one for the volleyball player, or we didn't do that one yet?
We didn't do that.
We did.
Wait.
Well, you're just looking for both where the y values are high. If you put,
I'm so confused. Okay,
you're
is
looking
this
for the
right?
x values. You need to put.
Okay, but there's
Yeah.
like more than that. And
And
then
then
more
you hit
lines.
intersect, hit analyze, and then you hit intersect, and you just look at the intersection, so it should show right up. Airplane.
Like, there should be 2 of them?
Yeah, because it hits 25 in 2 spots.
Are you collecting this? That
No, these are notes, because you're going to do the other parts later. The runway needed for a small airplane is blah, 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 where S is the speed of the airplane in feet per second. If a pilot is landing a small airplane on a runway that's 2,000 feet long, what's the maximum speed the pilot can land? So what you're looking at here is it's asking you, it's telling you that L is going to equal 2,000. What is S equal? So you set it equal. So you have 2,000 equals 0.1 S squared minus 3S plus 22. Set it equal to 0, you get 0.1 S squared minus 3S minus 1978. And what you're going to wind up doing here is you're going to get 2 possible values. One value would be positive, one value would be negative. For zeros, which one do you think you want to have? A positive speed or a negative speed?
Positive.
Dun, dun, dun. There's your answer. It's going in reverse. You put it in the graphing calculator, you look for the 0 that's positive, and that's your answer. What's going to happen here is this is going to be a curve that's positive, so it's going to be up like a cup. You're going to have a negative 0 and a positive 0. The positive 0 is what's going to make sense because speed can't be negative. Okay? Airplane. The next one's the cell phone, right?
Yes.
I want you guys to try to start the word problems. I know.
I can't read what this says.
Did I skip it? There we go. The amount of $1 billion spent on long distance phone calls in the United States modeled by this. We're teasing a number of years since 1989. What year did the the amount spent reached 60 billion. So what you're looking at here is nothing more than going right directly to your table. Everything here is in billions. So you put in your calculator 0.56 t squared plus point.
Oh, right. Because I was thinking like 560 and then took 0 off, would be like 56.
All you do is put that in your calculator, go to your table, and figure out after how many years did it get to be 60. If I'm not mistaken, let's see here. We have point 5.6
T squared plus 0.488 T plus 51.
and all I want to do is go right to my table. Menu, table. I'll split screen. Okay.
Then you have to look for it.
We're looking, this is years, 1 year, 2 year, 3 year, 4 year. So after the third year, it jumped over to 60 billion. So year 1 was what year according to that problem?
89.
So 89 is year 1, year 2 is 88, or 90, excuse me. So after 1991, 3 years later, it's over 60 billion. That's what you're looking at. You're just adding in time. Okay? What I'm trying to do here with these word problems is to show you guys that as awful as they look, once you start to realize what you're working with, it becomes really easy. Okay? So what I want you to do this weekend is I have like 8 of the word problems out of the book. That's the day 3 assignment. Do those over the weekend, okay?
So the
They-
77.
Yeah, whatever those are. There's nothing on there that's any scarier. It's actually pretty much along the same lines of these things. It probably shouldn't take more than 15, 20 minutes
What
tops.
number are you?
I don't remember the numbers off the top of my head, but it's the day 3 stuff on that little worksheet.
77 through 84.
Yeah. So it's the 77 through 84. Try your best on all those. Every single one of them in the book there, it should be pretty straightforward as far as the calculator stuff is concerned. I think there are also 2 of the ones that with like cost and sales, so you have sales and units. You might have to work back and forth off of that. But I really don't think there's going to be anything there that's going to be crazy, to be honest with you. Okay? We could have done more, but Lockhart talked a lot. I'm sure you're very upset about that.
Yeah.
Awesome.
I'm so excited. You see Tussin run around, come back here! I'm gonna tase you!
That's how you sound.
Yeah.
It is, yeah. Here's Tessa. I'm gonna get you!
Oh God. You probably just broke your stick.
It's never a dull moment in here, right?